Algorithmic thinking uncovers the inherent logic within daily processes. This includes understanding traffic flow as a system governed by rules. Automated systems also operate based on predefined algorithms. These processes are interconnected through visible data networks. Data networks reveal the order underlying seemingly chaotic urban systems. This highlights the structured nature of urban environments. Algorithmic thinking is a method of problem solving. It involves deconstructing complex problems into smaller steps. These steps are sequenced logically for clarity and efficiency. The core components are input, process, and output. Input defines the data or information needed. By organizing steps, complex issues become manageable. Structured thinking is a versatile approach applicable across diverse fields. It enhances both consistency and efficiency in various processes. A chef optimizing recipes exemplifies structured thinking in culinary arts. Students planning study schedules demonstrate its use in academic management. Logistics managers designing efficient routes apply structured thinking to supply chain operations. These examples highlight the broad applicability of structured thinking for process optimization. Data literacy involves the ability to interpret information. It also includes the ability to question information presented in various formats. These formats include charts and graphs. Understanding data enables individuals to derive meaningful insights and make informed decisions. Data-driven decision-making combines logical reasoning with data literacy. This approach transforms intuition into informed insights. Teams that use data outperform those relying on guesswork. Data-driven teams have a deeper understanding of results. They can identify underlying patterns in the data. This understanding leads to more effective and strategic choices. Algorithmic thinking provides a structured approach to problem solving. Data literacy provides the ability to derive meaning from information. The combination of both transforms raw information into actionable insights. This synergy translates abstract ideas into practical, implementable strategies. Algorithmic thinking involves identifying and generating patterns. Algorithms are visualized to emphasize the step-by-step nature of problem solving. Visual representations make the logical structure of algorithms more apparent. These visualizations aid in understanding the sequential flow of operations. Pattern recognition is a fundamental aspect of algorithmic design and analysis. Data literacy centers on the ability to interpret data effectively. The core of data interpretation lies in extracting relevant information. Visualizations transform raw data into meaningful insights. This transformation involves analysis and contextualization of the data. The integration of algorithmic thinking and data literacy enhances problem solving. Structured logic provides a framework for analyzing data. Data analysis informs and refines the logical processes. Combining logic and data analysis leads to actionable outcomes. This integration improves the effectiveness of decision-making processes. Algorithmic thinking and data literacy are broadly applicable across disciplines. These skills enhance efficiency in various tasks and processes. They also improve the quality and accuracy of decision-making. Visual examples demonstrate their versatility and wide-ranging applicability in diverse fields.